Hey everyone, today we are continuing using the Pythagorean theorem to solve for missing sides of a right triangle. In the previous two lessons, first we solved for a missing leg, then we solved for the missing hypotenuse. I separated them to two different dates. Today I'm mixing them all up. You'll have to determine, are we solving for a leg or are we solving for a hypotenuse? Okay, so we're going to do a couple examples together, and then you'll do an activity, of course, on your own. So just a general refresher, Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the two legs of the triangle and c is your hypotenuse. Okay, so like I said, today I mixed everything up. I didn't tell you if you're solving for a leg or you're solving for a hypotenuse. You have to be able to identify which side is missing because that's going to tell you how to use the Pythagorean theorem. So, step one is to look at the diagram that I gave you. Again, you need to be able to identify, are you missing a leg or are you missing a hypotenuse? So we need to know that the hypotenuse is the longest side of the triangle. It is also the side that is opposite of the right angle. So if you draw an arrow from the right angle, does it point towards the hypotenuse? Okay. Or if you draw an arrow from that right angle, whatever side it is pointing to is the hypotenuse. So if you look at this right triangle here, I am missing the hypotenuse. I know it's the hypotenuse because this is the side that is directly opposite of the right angle. So I gave you two legs. You need to solve for the hypotenuse here. So we're going to plug in the two legs into the Pythagorean theorem. Remember that with the Pythagorean theorem, the legs are A and B. Okay, so I'm going to plug in 7 and 11 for A and B, which was step 2. Step 3 is to square each of those legs. So 7 squared is equal to 49 and 11 squared is equal to 121. Okay, I'm then going to add these two legs squared together. Oops, it's supposed to be 49. Okay, 49 plus 121 is 170. Okay, so now I have 170 is equal to c squared. Again, we're solving an equation ultimately, so we need to get the variable c all by itself. Right now, it's not by itself, it's squared, so I need to do the opposite of squaring a number, which is taking the square root. But remember, whatever you do to one side of the equation, you must do to the other. So if I take the square root of this side, I also must take the square root of this side of the equation, which is what we're going to do. Okay, so I'm going to take the square root of 170 and the square root of c squared. The square root of c squared is simply c. And then the square root of 170 is going to give you a decimal because 170 is not a perfect square. So if I were to plug that into my calculator, we would get 13.03, so on. Be careful here. I told you to round your answer to the nearest tenth. Yesterday, I told you to round it to the nearest whole number. I switched it. You're rounding it to the nearest tenth. That means there is to be one digit after the decimal. Okay, so when I plug this into my calculator, I get 13.03. So again, I'm rounding this to the nearest tens, so this is going to round to 13.0. Yes, you have to include the 0 because I said round to the nearest tenth. Okay, so the length of this hypotenuse is equal to 13.0. Okay, next one, most important. Step 1, look at your diagram and determine, what are you solving for? Are you solving for a leg or are you solving for a hypotenuse? If you notice here, I gave you the hypotenuse. Okay, if I gave you the hypotenuse, then that means you're solving for a leg because that's your only other option. Again, I know I gave you a hypotenuse because I gave you the side that is directly opposite of the right angle. So that means I will now be plugging in a number for C and one of the legs, and I'll have one leg missing with no number plugged in. Okay, so I'm going to first plug in my leg, which I'm plugging in for B. And then I will be plugging in my hypotenuse, which is 20. Okay. Step 3 is to square both the leg and the hypotenuse. So 19 squared is 361, and 20 squared is 400. Okay, now I have a squared plus 361 is equal to 400. Guys, remember, we're solving an equation. So our next step is going to be to subtract the constant from both sides of the equation. So our constant is a number that doesn't have a variable next to it. So I'm going to be subtracting 361 on both sides of the equation. Okay, I didn't do anything with this a squared yet, so I simply bring that down. Okay, I didn't write it out, that step right here. I already wrote the square root for you, but you're just bringing that down. The 361s are going to cancel. Then I have to subtract 400 minus 361, and we get 39. Okay, so now I have a squared is equal to 39. I have to take the square root of both sides of the equation. Okay, the square root of a squared is simply a, and the square root of 39 is not a perfect square, so yet again, we're going to get a decimal that we have to round to the nearest tenth. And the square root of the square root of 39 rounded to the nearest tenth is 6.2. So the length of this leg of the triangle is equal to 6.2. Okay, next one. Look at the diagram. Determine what are you solving for. Are you solving for a leg or are you solving for a hypotenuse? Well, I am missing the side that is opposite of the right angle, which means we must be solving for a hypotenuse. So I gave you both legs, so please plug in both legs into your Pythagorean theorem. Next step is to square both legs. 8 squared is equal to 64, and 16 squared is equal to 256. Excuse me. Then add these two numbers together. 64 plus 256 gives us 320. So we now have 320 is equal to c squared. I got to get c all by itself, so I do the opposite of squaring a number, which is taking the square root. So I take the square root of both sides of the equation. Square root of 320 will give you a decimal, so we need to round to the nearest tenth. If I plug that into my calculator, I get 17.88. So if I round that to the nearest tenth, we get 17.9, and the square root of c squared is simply c. So the length of this hypotenuse is 17.9 feet. Okay, we'll do one more. If I look at this diagram, I notice that I gave you the hypotenuse because I gave you the side that is opposite of the right angle. So that must mean that I am missing a leg, so I need to solve for a leg. So I'm going to be plugging in a leg and the hypotenuse into my Pythagorean theorem. Again, guys, you need to know which one is which. So your leg is equal to 1 and your hypotenuse is equal to 4. Okay, now you're going to square these two numbers. You bring down the a squared. 1 squared is simply 1, and 4 squared is 16. Then we have a two-step equation right here. So your next step is to subtract the constant from both sides. So we're going to subtract 1 on both sides of the equation. Bring down the a squared. Your 1s are going to cancel. 16 minus 1 is 15. Okay, so now we have a squared is equal to 15. So I need to take the square root of both sides. When we take the square root of a squared, we simply get a. And when we take the square root of 15, 15 again is not a perfect square, so we will get a decimal. I'm asking you to round it to the nearest tenth. So when I take the square root of 15, we get 3.87. So if I'm rounding that to the nearest tenth, it will be 3.9. So the length of that leg of the triangle is 3.9 yards. Okay, guys, there are some other examples that you can, of course, look at, but you're now going to complete a mixed Pythagorean theorem code drag and drop that's listed on Google Classroom. Please read all the directions on that activity so you know what to do. But as always, please reach out if you guys have any questions.